You know. All right, so part B questions. Okay, part B questions. All right. Yeah. First few questions relatively simple. Yeah, but I saw some common problems. Yeah. So here, including those online students. Online students, I did 80% of the part B. Yeah. Yeah. All right. The first question, pretty easy, but I noticed some students, they just repeat the same problems in their homework assignment. Now, in the homework assignment, when I did grading homework assignment number 1, I noticed some problems. So then I gave you the solution, you know, I wrote the comments, you know, asked, you know, told those students, so you need to pay attention to those places. Because a few students, when they look at the sequence here, they treat it as a arithmetic series. You know, the difference between two adjacent numbers the same. You know, actually it's not, right? Yeah. If you look at, they look at the number by number. Okay, the difference between 7 and 8 is 1. Then the difference between these two adjacent 2. Yeah. So it's not we call it arithmetic series. It's not that, because they apply the formula for the arithmetic series. There is a formula. You know, the first number you plus the last number divided by 2, then multiply the number of numbers. They use that formula. Then you get it wrong. Okay, several students did that. Okay, so here I'm talking about the 2 classes. Yeah, yeah. So your class a little better. So that online class, more students did in that way. Okay, yeah. But when I give you the solution to the homework number 1, yeah, those students, you look at the solution, you should fix that. Yeah. All right. Otherwise, it's a pretty easy question. Yeah. Yeah. So here, I do not need to talk too much. Yeah. But I just saw those students, they repeat the same problems in their homework assignment. Yeah. And the second question, the biggest problem is many students, because you need to figure out the formula for the subscripts or superscripts. Yeah. The formula here is because the difference between two adjacent subscripts by 4, right? So it should be 4k plus 3. The formula, you need to look at 4k plus 3, that formula. But so many students give me 3k plus 4, right? You know, quite some students give me 3k plus 4. The formula is wrong. Yeah, yeah. Yeah. That's the common problem. Yeah, yeah. Other than that, you know, should be okay. Yeah. All right. So that's the first 2 questions. Yeah. All right. Then the third one. Yeah. The third one, a lot of problems. Yeah. So here, you know, the biggest problem, yeah, because here we have a condition. Okay, we have a special condition. So you need to use this information. Yeah. This information helps you to reduce the number of comparisons. Yeah. Many students didn't use this condition. Okay? They ignored this condition. Yeah. They just apply the formula directly. You know, there is this formula, right? Yeah. Directly on, you know, n equals 21. Yeah. Some students, you know, change that number. Yeah. If you change it in the correct way, then it's correct. But you need to make sure your change, there is some, good reason behind it. Yeah, so I will talk about that. Yeah, one student did that. Yeah, that's good. One student in our class did that. Yeah. All right. Yeah, Kirill, as I remember. So, yeah. So I will talk about his method. Yeah. So very special. Yeah, but yeah, not easy to see. Not easy to see. Yeah. All right. Yeah. So, yeah, let me show you that idea. That idea. So we split the elements into two parts. The first three elements. Then the remaining part starting from x to the x sub 4, to the end. Yeah. And the remaining, we know there are 18 elements, right? The remaining 18. That number equals 18. Yeah. 18 elements. Yeah. But how do we treat the first three elements? How do we view first elements? Yeah. So let me talk about Kirill's idea first. Yeah. Yeah. All right. Yeah. His idea treated these three elements can be used, these three elements can be used, let's say, can be treated as one new element. Yeah. So if we use x0, for example. Yeah. So the role these three elements play is equivalent to another new element added to the group. Equivalent. But you need to see it. Yeah. It's not easy to see it. Yeah. Yeah. Actually, it's a very interesting view. Why equivalent? You need to explain, right? Yeah. All right, so here, I try to figure out, my understanding. Yeah. I think it's correct. It's a nice view. It's correct. The thing is, although here you see three elements, right? Yeah. x2 is gone, right? Because x2. Sorry. Yeah, both maximum and minimum. x2 cannot be maximum, cannot be minimum. We can safely remove x2. Yeah, no problem. So there is only x1 and x3. Okay, x1, x3. But why can we replace x1, x3 by one new element, x0? Yeah, the idea is like that. 18 is an even number, right? This 18 is an even number. Yeah. Even number, we can pair them in a perfect way, right? Yeah. Then, after we add the last element, then it becomes an odd number. Then the other one should be treated differently, right? First, we cannot pair it. Other one, we have to leave it out when we do pairing, right? Yeah, we leave it out. But this other one, after we do the tournament method, that other one, we need to bring it back to join winners group and the losers group, right? So that other one element, need to join both winners group and both losers group. You can see the other one actually is split into two parts. One half goes to winners group, one half goes to losers group. Then that's the same thing here. Our x1, x3, we split into two halves. x3 goes to the winners group, x1 goes to losers. So the role is equivalent, right? So if we glue x1, x3 together, okay, so it's a one element. Okay, but when we need to, the second round, when we need to, find the max in winners group, min in the losers group, we need to split. When we split, we take x3 as the first half, top half of x0, join the winners group. Then we treat x1 as the bottom half, join the losers group. The same. same rule, right? Same effect. Yeah. Kiri, did you understand in that way? Oh, yeah, that's great. Yeah, that's brilliant. Yeah, because I didn't do it that way. I didn't view it that way. Yeah, so that's why I like that. Yeah, yeah. Matthew, how did you do this one?
Oh, I don't think I wrote it exactly what you said, but I saw that relation. I'm like, oh, okay, so you have an even number initially, and then you have the first three. So
yeah.
breaking that out, you're reintroducing, you have 19 on one side, you determine the extra round, or you have 18.
Yeah. Did I wrote some? Oh, yeah, you did a similar way. Yeah. But when I look at your solution, I didn't see, the logic behind it. Yeah, so it took me a while, but I couldn't see it. Right, yeah. Yeah, but after I look at the Kiri's solution, now then I understand. But I did yours before I did his grading, so that's why. After I did his grading, now when I see your solution, then it looks, makes sense. Yeah, good, very good. Yeah. All right. Yeah. So, I mean, I like this view a lot. Yeah. It's not easy to see. Yeah. Yeah. It's not very easy to see. Yeah. All right. But my way. Yeah. I will post my solution. Yeah. So I complete. Part B, part C. Detail my solutions. Yeah. I will post them after class. Oh. Yeah. Let me see. Yeah, let me double check. Yeah. Yeah. Because one student still working on, but at our test time, that student was sick, yeah. So I asked him, doing, this time, outside, yeah. So I want to make sure, all students complete it. Then I can post the answers. Yeah. All right. Yeah, but when I did a grading, most students, they wrote some winners group, losers group, comparisons, but so many students miss the tournament round. Okay? Yeah, large number of students from both classes, they miss the tournament round. Yeah. Okay? Yeah. Yeah, so many. Yeah. So that's the biggest common problem. Okay? Because we need to do the tournament round, right? Missed the tournament round. All right. So that's the biggest common mistake. Yeah. The tournament round, we pair x4, x5. Yeah, x4, x5. The first pair, x6, x7. Second pair, and so on. Okay. The last pair, x20, x21. Yeah. How many pairs? Yeah, you need to figure out 18 divided by 2, 9 pairs, right? Yeah. 9 pairs. 21 minus 3, 18. 18 divided by 2, 9 pairs. Yeah. So this round, the tournament round, nine comparisons, right? Yeah. So some students missed this 9 comparison this round. Yeah. Because so they directly those students gave me the winners group. Oh, winners group, because you need to, those students, they know x3 should join. X3 should join the winners group, okay? X1 should join losers group. So you get 10. 10 elements. 10 elements in winners group, so you get another 9 comparisons. Okay? Yeah, another 9 comparisons. Yeah. But some students miss the tournament round. Okay? Yeah. So that's one common mistake. Yeah. Another common mistake. Yeah. So those students, they didn't miss the tournament round. Yeah. Yeah. Yeah, but those students are, yeah, so, yeah, one group students, apply this formula directly. Yeah, another students, another round. Many students, give me the, what's that? Yeah, after 21. Oh, yeah, that's the same group of students. Yeah, because if you plug in 21, 3 times 21 divided by 2, seeding function minus 2, okay? Yeah, 63, 64, 32 divided by 2, 32 minus 2, 30, yeah. Many students give me this 30 number. Yeah, 30 number, yeah. The same group students. Yeah. Some students give me the formula. Some students give me 30 number but didn't give me the formula. Yeah. Quite some students didn't give me formula. Yeah. Here I include online students. Yeah. For your class, so you didn't have that many. Yeah. But that online class, so many students did it in this way. Yeah. All right. And later we have a similar question. Yeah, later that question is similar to this one, but the same problem. Yeah. All right, so here, the answer, because 3 nines, the answer is 27. 3 nines adding together, 3 nines. Yeah, okay, yeah. All right, that's question number 3. Number 4, yeah, number 4 easy, yeah. But small number of students missed. One student gave me 3, one student gave me 2. 3 is a prime, right? Yeah. 2, not an odd number. Yeah. 3, at least it's a prime. It's an odd number. Yeah. 2, it's not an odd number. Yeah. One student gave me 2. Yeah. 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 Most of you, give me the correct answer, 9. Odd number, but it cannot be prime number. Yeah. That's simple. Yeah. All right. Number 5, yeah, a lot of problems in number 5. Yeah. So here I talk about a few common mistakes. Yeah. All right. Answer is 3 comparisons. 3 comparisons. Yeah. To find it, actually, it's not that hard. Yeah, yeah. But many students, give me best case, not the worst case. Many students give me 2 comparisons. Yeah, large number. Yeah, yeah. 2 comparisons. That's the most common mistake. Yeah, I look at their work. Okay, I look at some students put some work there. I look at the work. It's not the worst case. Okay, yeah, it's not the worst case. Yeah, yeah, yeah. All right. And one student, yeah, here, remember, there are element number 5. Yeah. In the condition, I do not talk about element 5. Yeah. But it does not mean that element 5 does not exist, right? We have element 5. But one student ignore the element 5, okay? Yeah. Right. Yeah. So then, that's, not too many students did that way, okay? Yeah. As I remember, only one student did in that way. Yeah. But most students, yeah, when they did the comparison, many students did. When they did the comparison, they ignored x2. Okay? Yeah. Many students. So they compare. Yeah. First they compare x3 and x5. Okay. x3 and x5. Yeah. Yeah. So let's look at the typical way. Those students, they missed this question. So many did in that way. So I want to talk about. So the student, that first comparison, x3 and x5. Okay? Yeah. Now one is larger, one is smaller. Okay? If x3 larger, x3 is the largest. Yeah. So there are 2 cases. x3 greater than x5. Yeah. Second case, x3 less than x5. Yeah. All right. if x3 less than that, x5 is the largest. Yeah. Largest. Then we need to find the second largest. Okay? Second largest, then, yeah, x3 is second largest, right? Yeah, because in this case, so, yeah, this is the best case. This is the best case. Best case, only one comparison. Okay, all right. Then, so for the worst case, we need to focus on this is. Yeah, so we assume x3 greater than x5. x3 greater than x5, x3 is the largest. Okay? Yeah. So x3. So we can eliminate it. So we only need to find the second largest. So after we eliminate x3, what are the candidates for the second largest? So here, the biggest problem is in this step. Yeah, I look at those the solution. The candidates for, so here we're talking about this case, okay? Yeah, for the second largest. Candidate, okay? Candidate, those students only give me two elements candidate, x4 and x5, but actually x2 is also the candidate. x2, x4, and x5, yeah. But those students, many of those students, yeah, they missed to put x2 in the candidates. Yeah. So they feel by their intuition, they feel x2 cannot be the second largest. Think about how do you eliminate x2 to be the second largest? You do not know x2 is larger or x4 is larger, right? You do not know. Yeah. So all of these three elements are qualified to be the candidates of the second largest. But when you need to find the largest, you need two more comparisons. Largest, right? Yeah. Two more to get the second largest. Second largest, yeah, second overall largest, okay? Yeah, second overall largest. Yeah. So the common mistake, they skip that x2. Yeah. Yeah. So that's why those students give me two comparisons, okay? Two comparisons. Yeah, yeah, that's the biggest common mistake. Yeah. All right. That's this question. All right. Next question, number 6. Similar to number 3, right? Yeah. But here, yeah, I know it's similar, but here you have 3 inequalities. Yeah. 3 inequalities. Yeah. So, all right. But a lot of problems. A lot of problems here. All right, so we group the elements in two parts. Yeah. The first part, the first 9 elements. Okay, yeah. x1 less than x2 less than x3, x4 less than x5 less than x6, x7 less than x8 less than x9. The middle 3 elements can be eliminated, right? Yeah. Yeah. Because they cannot be maximum minimum. So the first, the easy elimination, the middle 3 elements. There, these 3 can winners group, right? We'll go to winners group. And these 3 should go to the losers group. Right? Yeah. Yeah. All right. That tournament method. Tournament part, yeah. So that's what I mentioned in the previous example. so many students that miss the tournament round. Yeah. Regarding, mainly for this question. Yeah. This question, large number of students, tournament round. All right, tournament round, starting from X10, X11, okay, one pair, 12, 13, yeah. But here we have 5 pairs, right? Yeah. 14, 15, yeah. 16, 17, 18, 19, 5 pair. So this tournament round, 5 comparisons. Yeah, tournament. Yeah. So do not miss this round. Tournament. Okay, this round. But there are some students, they consider, they consider the elements from this side in the tournament round. Yeah, some students did that. Yeah, all right. But if you do correctly, that's okay. Yeah, yeah, all right. So then, the next round. When you form the winners group, you need to add 3 elements. X3, X6, X9, okay? These 3 added to winners group. Losers group, you need to add X1, X4, X7, add to the losers group. Yeah. Then you find the max, minimum. Okay? Yeah. Yeah. All right. So tournament 5, all right? Yeah. After you add, you get 8 elements. So each group you have 8 elements, 3 plus 5. 8 minus 1, 7, right? 7. Losers group also 7, 19. 19. So many students, some still give me 21. Yeah. 21. Okay? Yeah. 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 For this one, if we compare with the previous question number 3. Question number 3, because we only have one inequality, right? Yes. We only have one. Here we have 3 inequalities. Yeah. So in that one, previous one, we can use curious method. So we treat those 3 elements, as one equivalent new element. Yeah. But here you can see that idea. So if you want to extend it in this situation, then you should be very careful. Yeah, because if you use 1, yeah, but here we have 3. So that may not be easy way to use that. Yeah. So this method is safer. Yeah. This method is safer. So you do not need that special view, because that special view you may misunderstand. Sometimes you can misunderstand. If you have one triple elements, yeah, we treat x1, 2, 3. We treat that as a one triple. Yeah, we consider them together as a triple object. Okay, yeah, triple sum object. Yeah, 3 sum object. Yeah. Yeah, but here. 3 triples. So then, if you use it in the wrong way, then you mess up. Okay, yeah. But this method, our tournament method. Yeah, so that's safer. Yeah. Tournament winners group, losers group. So that will be safer. Okay, all right. Yeah, so that's the number 6. Yeah. Number 7, number 7. Yeah. The biggest common mistake is many students, they only use repeated squaring. Then answer one more. Then the best answer. Best answer, 10 multiplications. But you need to do some cube operation. Yeah. You mix square operation and the cube operation to get the best answer. But quite some students, they only use square operation. They do not use any cube operations. Their answer is one more than the best answer. No. That's the, comparisons. But you need to use square mix. Yeah. So what do you need to do? The best way. Yeah. Mix. Yeah. Square ops and cube ops. The reason is very simple. This 234, this number is special here. Yeah. 234 is a multiple of 9. Okay? Yeah. Not just multiple of 3, multiple of 9. So how can you say multiple of 9? Because 2 plus 3 plus 4, that's 9, right? The digits, you add, you take the sum of all the digits. 2 plus 3 plus 4, it's 9. If the sum of all the digits is a multiple of 9, then this number is a multiple of 9. Yeah. In number theory, there is a simple property. If the sum is a multiple of 3, sum of the digits is a multiple of 3, then this number is a multiple of 3. Yeah. Yeah. But here, because it's a multiple of 9, so it's a multiple of 9. Yeah. So 9 times 2, okay, yeah, 5, 26, right? Yeah. Yeah, because why this 9 tells you some important information. 9 equals 3 squared, right? 9 equals 3 squared. 3, somewhat related to cube, right? Yeah, multiple of 3, related to cube. But here, it's a 3 squared. So this gives you the strong information. It's strongly related to the cube operation. If you only have 3 factor, so related to cube, but not that strong, okay? It's just a multiple of 3. But here it's a multiple of 9. So it's a 3 squared multiple. The multiple of 3 squared. Then it gives you a very strong, yeah, so here, so that's our understanding, okay? Yeah, because when you see something, how you understand, yeah, so everybody see the same thing, right? Yeah, everybody. What you can see, the same thing. Yeah. But how do you understand the same thing? That's different. Okay? Different people that understand differently. Yeah. Yeah. So here, so we emphasize understanding. So here, this information give a multiple of 9. First, are you aware of it's a multiple of 9? So the first question. You may not be aware of it, right? Yeah. 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 So first you need to be aware of that. It's a multiple of 9. Second, multiple of 3 squared. So strongly, it gives you the, information. It strongly favor the cube operation. Yeah. So here the result tells you, you need to apply some cube operation, yeah, to get the best answer. Okay. Yeah. All right. Yeah. The detail in my solution, so I do not need to, write the detailed formula. Yeah, I will post my solution. Here I'm just talking about, I do the analysis on the errors, the reasons behind the errors. I want to do that, yeah. In your problem solving, yeah. So how do you think in the right way? I want to focus on that part, yeah. The detail, yeah, I post the answer, yeah. All right. Number 18, yeah. Another, yeah. So this one, the answer 12 multiplications, yeah. But some students give me much larger number, yeah. Many students give me 16, yeah. Many students give me 16, yeah. So here the correct answer is 12 multiplications. The reason is simple. Those students, they didn't use their resource efficiently. Yeah. We know we want to reuse the resource, right? Yeah. Yeah. Because the reason, let me explain why those students got the, large number of students give me 16. Okay. Yeah. So as large, you can see the difference is so large, as large as 16. Okay. This is the most common mistake. Yeah. 4 more than the best answer. Yeah. So that's a big difference. Yeah. 4 more. Why? Yeah, the answer is, yeah. Because some students, they split. Okay. Yeah. They represent x to the 43rd. Yeah. Yeah. Then separately, x to the 90th, another way of representation. Then x to the 133, yeah. Then add them up. Yeah. Because in this way, yeah, you didn't take advantage of the special property of these terms. Yeah. Because by the special, you can reuse, because your x33, after you calculate x to the 43rd, you can reuse it. Yeah, so that students, they didn't realize. You can reuse it, because when they do this from scratch, you didn't reuse x to the 43rd, right? So the problem is reuse. Yeah, here, x to the 3rd, so reuse x to the 43rd. But when they calculate x to the 90th, they start from scratch, okay? Then they do more work. When they calculate x to the 130th, start from scratch, okay? Yeah. Yeah. So that's one type of common mistake. Yeah. All right. All right. Yeah. And yeah. Here also, yeah, you need to multiply A and multiply B. Yeah. But when they separate, I look at the numbers, they add it together. They didn't count that the A multiplication and the B multiplication. They didn't count that. Even they didn't count A multiplication, they still give me 16. Okay? If you count A multiplication B, you have 2 more, 18. Yeah. Okay? So that's not efficient. Yeah. All right. The correct way, the factorization. Do as much factorization as possible. Yeah. Here. X to the 43rd, 1 factorization. All right. Yeah. So then, because you want to reuse x to the 34, right? Then x to the 4th. Yeah. Because after that, you have another. Yeah. Then A plus B times x to the 43rd. Yeah. Okay. This factorization. Then you can see in this factorization you maximize the usage of x to the 43rd. You maximize the usage. Okay. So you use it 3 times. Okay, you calculate it once, but you use it 3 times. Yeah. Yeah. All right. All right. Yeah. All right. Yeah. Yeah. So that's number 8. Number 19, big miss. Yeah, this one. You know, most students. Oh, yeah. I think only very small numbers got this one. You know. Yeah. As small as 1 or 2 students. Yeah. Yeah. You know, correct answer is 8 multiplications. You know, it give me much more than this number. Yeah. 8 multiplications. The biggest problem is and how to reuse this square sharing. Oh, sorry. Let's say how to share the squares as much as possible. That's the biggest problem. How to, because we want to share the square operations as much as possible. Greedy algorithm, right? As much as possible. That's the greedy algorithm. Okay? That's the main issue here. Yeah. For this question, why so many students, yeah, I like to say approximately 90% of the students missed this one. 90%. Only 10% got this one. Okay? 90% missed this one. Yeah. The reason is they didn't share the squares in the maximum sense. Or they are not greedy enough. You can say in that way. They are not greedy enough. Yeah. So, yeah, let me show you. So why I say, you know, they didn't squeeze the, you know, juice out of it enough. You know, you can understand it that way. Yeah, let's do it one by one. Yeah. I look at the detail. Yeah. Actually, we can do more. You can do more square sharing, but they didn't. Every time when you do 1 square sharing, you reduce multiplication at least by 1. Sometimes you can do 1 square sharing, you can reduce multiplication more than 1. Yeah. All right. First, yeah, here I have some space. I can write a share. Step by step, I show you how to square the maximum amount of juice from it. Yeah. Now let me look at the time. Yeah, yeah. Good. I have some time. Yep. Because for part C, I do not have to complete part C. Yeah. Part C, especially the last question, very difficult. So I can talk about that later. Yeah. I will post my solution. Yeah. The last question is the hardest. Yeah. So you know, that was a new question. The first time I used that question, I created. Yeah. But when I wrote a solution, I used many hours to write a solution. I need to draw figures. Okay. I need to, you know, repeatedly improve my solution. Yeah. So that one, yeah, I spent many hours. You know, at least 5 hours on that solution. You know. Yeah. So that's a very complicated one. Yeah. But the end result is not that messy. Yeah. End result, yeah, looks fine. Yeah. Not too messy. Yeah. Yeah. All right. Yeah. Now square. Let's look at the square sharing. The first step, easiest. Everybody can see it. Yeah. But when you go more and more steps, before I do the square sharing, let me tell you another common mistake. Yeah. Large number of students did this kind of common mistake. Yeah. Yeah. All right. Then they didn't look at the whole thing. They separate. Yeah. So because they represent u to the 4th. How many multiplications? Then v to the 6th. How many multiplications? So they did separately. If you do in that one, then multiply them together. So then you need to use too many multiplications. Yeah. Because in this way, you cannot share squares. When you separate these terms, separate these, powers, power structure. Okay? So you didn't take advantage of the square sharing property. Yeah. Yeah. That's the main problem. Yeah. At least half of the students did it this way. Then the remaining, they know square sharing, but they didn't do strong enough. Yeah. So let me show you. Those students, when they did a square sharing, the first round, no problem. Everybody can do that. Yeah. Everybody can do that, first round. Yeah. Because one square sharing. U square V cube W to the 4th Z to the 6th. Yeah. Everybody can get that. Yeah. Yeah. All right. The second one, then because here you have a V cube. Yeah. So you cannot, because it's an odd number. Yeah. So this student got a problem here. Yeah. How to understand this V cube, the contribution of V cube, give them problem. Okay? Yeah. All right. So here, this step, V cube, can we take out one V, right? Yeah, so V. If we take out one V, then all of them have even exponent. Yeah. Then the remaining we can do second round square sharing. Okay? Yeah. So U V W square Z cube, second round square sharing, right? Okay? All right. Then, yeah. Inside the innermost parenthesis, U is down, V is down, right? Yeah. But W, you have square, Z cube, so you can take one Z out, you can share another round square. Yeah. So, all right. So this V times U dot V dot Z, right? We can take out another one Z out. After you take out that, so you have W Z square. Yeah. The third round square. Square. Okay? Yeah. So you share square 3 times. 3 rounds. Yeah. 3 rounds. But you can see the power of this 3 rounds square sharing. First round square sharing covering all these numbers. Okay? The second round square sharing, so the second round covering all these numbers. Okay? The third round coverage small, but first 2 rounds cover many operands. Yeah, let's say operands, multiplication operands, right? Yeah, so more efficient. Yeah. Then in that way you count the number of multiplications. Yeah. So if you get this structure, you cannot miss it. Yeah, just count it carefully. You cannot miss it. Yeah. All right. The last question of part B. Last question. Yeah. the problem still, the common problem as in the homework assignment. In the homework assignment, many students didn't use the Pascal's triangle structure. Here still, quite some students, they didn't use Pascal's structure. They still count directly. Not too many. Too many. The answer is 6 multiplications. Yeah, so many students give me, 10 something, 20 something, 30 something. That large number. Okay? So the first thing you need to recognize, it matches the structure of Pascal's triangle. So the first step, you need to recognize it's a Pascal's triangle. Right? By Pascal triangle, you write a of x plus b of x to the 5th. The first step. Right? But the second step, many students, they forgot the Horner's rule. So many students, they just count the multiplication directly. They didn't use the Horner's rule. That's another common mistake. The second one, you need to apply the Horner's rule. Okay? All right. AX plus BX, you need to combine the terms. Some students didn't combine the terms. Okay? Yeah. Count the multiplication in A of X independently, then multiplication in B of X independently. Didn't combine. Yeah. So you need to combine, because our homework, if you look at the solution homework, we combine. Yeah, but the student, they didn't look at the solution of the homework assignment. A0 plus B0, A1 plus B1, X, A2 plus B2, X squared. And some students missed the last term. Yeah. So this one, we have a last term. Horner's rule. Okay? Horner's rule. By Horner's rule, this gives you 3 multiplications. But so many students give me 6 multiplications. Okay? Because 1 here, 2, 3. 1 plus 2 plus 3. So you double it. By Horner's rule, we only need to use 3 multiplications, but those students, they double it. So they give me 6. Okay? Yeah? So you can see. Yeah. So if you understand our homework solutions, you cannot miss it. Yeah. So many students. Yeah. So here you can see the basic understanding, how important it is. Yeah. So I didn't do a lot of change. Yeah. I didn't do a lot of change. Yeah. Yeah. Some students, they did quite well. Yeah. Because it's so easy. Yeah. Right? Yeah. All right. Yeah, so I have 15 minutes. Yeah, but let me try to explain 1 or 2 questions in part C. Yeah. Part C. Yeah, part C. Okay. Yeah. Part C. Yeah. Number 3, number 4 actually closely related. Number 3, number 4, closely related. Yeah. Okay. Yeah. Yeah. All right. Number 1, 7 elements. Yeah. X1 not the minimum. X1 not equal to the minimum. X7 not equal to maximum. Yeah. But X4 not equal to minimum and a maximum. All right? Yeah. Now we need to find both maximum and minimum. Okay, yeah. Both manual, so X4 can be eliminated, right? Yeah. So gone. Gone. Okay. All right. So you only need to consider the remaining. The remaining, not a minimum, so it can join the winners group, right? So the X1 should join the winners group. Not the maximum, so it can join the losers group. Okay? Yeah. So then the remaining X4, sorry. Oh, no. Cancel. Yeah. X4 is gone. Yeah. Okay. And 1, 7. Yeah. Then the remaining, you form two pairs, X2, X3, X5, 5, 6. Yeah. Yeah, yeah. It's not important. Yeah. 6. Okay. So winners group, losers group, winners group, you add X1. Okay. Losers group, you add X7. Okay. So there you. Yeah. Yeah. Right. Yeah. So here you can see this kind of question we did so many times. Yeah. We need to get used to it. Yeah. Not hard. Yeah. So get used to the thinking. Yeah. The thinking. Yeah. All right. Many students lost the 2 points in this question. Yeah. So they did partially correct. Lost the 2 points. Yeah. So you miss some places. Yeah. Miss some places. Okay. Yeah. Yeah. All right. Yeah. All right. Yeah. So number 12. Yeah. Question? Answer? All right, let's see the answer. All right, answer. Right. Yeah. Okay, so we didn't do, yeah, eliminate, yeah, didn't do. All right, so 2 here, right? Yeah, 2 here. Then plus 2 here and the 2, 6. 6 comparisons. Oh, many students give me 8 comparisons. Yeah, so now I see it. Yeah, so many. Yeah, not just 1 or 2. Yeah. Yeah. It's pretty common. Yeah, I saw 8 comparisons. Not the best. Yeah. Yeah. Okay. Yeah. Yeah. 6 comparisons. The second one, 5 comparison, but 5 comparisons, but most of you give me 6 comparisons. Yeah, yeah, Yeah. In this class, I picked the top 4 students, from part B, the top 4 students in this class, yeah, who got more than 30 points, 30 out of 40. Yeah, yeah. I mean, I look at those, They couldn't give me 5 comparisons. They gave me 4 comparisons, 6 comparisons. Yeah. Here, let me tell you. So why? So they didn't use the information efficient enough. Yeah. So they waste some places. So they waste some valuable information somewhere. Wasted. Okay. All right. Yeah. All right. So why? So here, I have a few minutes. Let me just explain the key part. Yeah. All right. Determine. The first part, that's easy. So many students got that. So because if you look at it, X2 cannot be the maximum, cannot be the minimum. So X2 already satisfy the requirement. Okay. The target requirement. Okay, so X2 should be selected, right? So we just need 3 more 3 more elements not in maximum minimum group. Okay, yeah. 3 more. Okay, yeah. So 3 more to go. Yeah. So, but when you find 3 more extra elements, okay, yeah. So you need to use the information in a careful way. Careful, smart arrangement, careful way. That's important. Yeah. Oh, yeah. Let me mention, some students, they didn't give me the best answer. Yeah. Some students, so they didn't consider the special information we already have. So one student, because you need 4 elements, not a maximum, minimum. Then we add 2 more. So, you just consider 6 elements. Then we find a maximum, minimum. We remove. We get a 4. In that way, you didn't use the given information. Yeah, you just ignore the given condition. Then you use the 1 more comparison. Yeah. So that's the reason. But if you use the given condition, you can save 1 comparison. Here, let me tell you how to say. Yeah. 3 more to go, all right? Yeah. So that means because your answer, you need to find the 3 elements, not maximum, minimum. Then you need to add 1 local maximum, 1 local minimum. You need to get 5 elements, right? Yeah. So here is, all right. So we separate, because the first group, x1, x2, x3. Other than that, x4, x5, x6, x7. Okay. Yeah. x2. So we take it out. Yeah. So it's in our target pool. Okay. Target pool. Okay? All right. Then x1, x3. x1, x3 has the information x3 greater than x1. So this information, we should use it. Yeah. So we have a winner and a loser. x3 is the winner. x1 is the loser. Yeah. So that information we should. So x3 should go to the winners group directly. x1 should go to the losers group directly. x3, x1, losers group directly without comparison, right? So that information, because we don't need a comparison, we can go to winners group, losers group, all right? So then, the remaining 4 elements, we only need to choose 3 of them. We don't need a 4th one. The smaller, the better. If you choose more elements, you need to do more work. So we just choose the minimum number of elements that we need. Yeah. So the 3, x4, x5, x6. Yeah. All right. Then, tournament method. Okay, tournament. Yeah. But the tournament method, the first pair, we already have x3 winning over x1. Yeah, so we have that result without comparison. Yeah, but we put there. Okay, we put there. Yeah, all right. Then remaining 3, we can only form 1 pair. Okay, yeah, 1 pair. Yeah. Let's say x5 over x4. All right. Then x6. x6 can join both winners group and the losers group. Okay. Yeah. Winners group, we need to include it. Losers group, we also need to include it. Okay. Yeah. So that's winners group. That's the losers group. Okay. Include it. All right. Then our last round. Yeah, we still have a few minutes. We can complete the last step. Yeah. Last round. Winners group, we need to find the maximum. Okay. We need to find the maximum. Yeah. All right. So here, tournament, there is already one comparison, right? Yeah, one comparison. So this tournament, this is the one comparison we use in this tournament method. Yeah. All right. Then, the winners group, 3 elements in the winners group. To find the maximum, we need 2 comparisons, right? 2 comparison for local. Here I call local max because it's not a global max. Different from global max, local max. All right. So the losers group, we need 2 comparisons for local minimum. Local minimum. All right? Yeah. Yeah. All right. So 1 plus 2 plus 2, 5. Yeah. Because, yeah. But here, yeah. So here you already count the number comparison. 1 plus 2 plus 2 equals 5. Yeah. But you need to do some, further clarification, because there's some complexity there. Yeah. All right. The problem is because we want to work on the worst case. We want to work on the worst case. Yeah. All right. Yeah. So here the question is, when we find the local maximum of the winners group, the question, can X6 be the local maximum of the winners group? Is it possible for X6 to be the winner of the local maximum of the winners group? Is it possible? Yeah. Let's use this logic thinking. Yeah. If X6 is the local maximum in the winners group, then X6 cannot be the local minimum in the losers group, right? If X6 cannot be the local minimum in the loser group, we eliminate X6 in the losers group. Then in the loser group, we only need 1 comparison, right? Yeah. If 1 comparison, it's not the worst case. Yeah. Because if X6 is not the local maximum, we use other elements as the maximum, then X6 still need to join comparison for the local minimum, right? We still need 2 comparison. So here you can see, based on that analysis, X6 should not be the local maximum and the local minimum. Otherwise, it's not the worst case. Okay? Yeah. X6 cannot be different from local max, and similarly cannot be the local minimum. Because the reason is because people may find the local minimum first, right? Yeah. Because these 2 groups, people can pick randomly, right? So which one you want to random select it, okay? Yeah. So here we should consider, because people can choose a different group to first. Yeah. So in that logic, so X6 cannot be the local maximum, X6 cannot be the local minimum. Yeah. Then, so you can choose, for example, X5 local maximum, and here X1 local minimum. Then it forces you, this strategy, it forces you to 2 comparison in the winners group, 2 comparison in the loser group to maximize your work, right? Maximize your work. You need to do 4 comparisons to get the local maximum, local minimum, plus 1 in the tournament, total 5. 5 covering the worst case. Okay? That's worst case. All right? Yeah. So that's why this is relatively hard, because you need to do so much analysis work. Yeah. All right? Yeah. So it's all in my solution. Yeah. Here you see the very messy, but I have a clean solution there. Okay. Yeah. So you don't worry. Yeah. Yeah. All right. So sorry, I used 2 more minutes. Yeah, sorry.